So we're going to look at the exponential functions. Now these are things that you have seen before, but just to go over a couple of key things. We have an increasing function when our exponent has a base that is bigger than 1. We have a decreasing function when our base is a fraction, so it's between 0 and 1. So just a quick refresher of some of the basics of the graphs. If it helps you remember, these are your fractional bases. Okay. We're going to also look at all the exponent rules and do a quick little review of those because we will be using those as well this unit. So the laws of the exponents that you should know, and you should have seen these all since grade 8 or grade 9. Whenever you have a base raised to any power of 0, or a power of 0, it has to equal to 1. And if we have any base with exponents x and y, if they are being multiplied, we can then add their exponents. If we have a base raised to a power of x raised to a power of y that's being divided, we can subtract their exponents. Whenever we have a negative exponent, it's the same thing as making it to a 1 over b to the x with a positive exponent. If we have a power to a power, b to the x, all raised to the power of y, it's the same as multiplying your exponents. And when we have fractional exponents, those are the same as having a radical. The denominator becomes our root, the x remains our power. Some of you may have recalled seeing it written as this. They mean the same thing. You can either apply the root first or apply the power first. Either one. Now we're going to look at the derivatives of an exponential. Now, there's a little bit of a little side note here. We're going to come back to this in a couple of sections. If we have the derivative of any base to the power of x, we can actually solve it by finding this function m of b. M of b is defined to be the limit as your h is approaching 0 of b to the h minus 1 all over h, multiplied then by b to the x. Now, we aren't going to do any calculations with bases right now because we're going to look at a few more things to do with logarithms first. But there is our nice e, our irrational number e, which is approximately 2.718, etc., etc. It's an irrational number, but it happens to have the nice property that when you take this limit, it's equal to 1. So the derivative of e to the x is actually equal to e to the x. So this is what we're going to be focusing on in terms of our exponentials with derivatives so far. So because our derivative of e to the x is e to the x, the integral of e to the x dx is equal to e to the x plus c, some constant, which makes it very nice to work with when we're working with some examples of how to actually do derivatives and integrals. So if we want to take the derivative of e to the negative 5x, now this is going to use chain rule. Everybody's okay with that because we have to have a function with something plugged in. So the f of x is going to be e to the x, or g of x, what we're plugging into our exponent, negative 5x. The derivative of e to the x is e to the x. Nice and easy. The derivative of what we're plugging in here is going to be negative 5. So if I take the derivative with respect to x of e to the negative 5 of x, if we use chain rule, take the overarching function and we plug in our g to the x, and then we multiply it by the derivative of g of the x, which simplifies down to negative 5e to the negative 5x. So now, if we want to look at taking the integral of a function, in this case e to the 4x, we're also going to have to use our u substitution. We're going to let u be 4x, then du is going to become 4 dx. To get just dx by itself, we divide both sides by 4, and then we can write it as the integral of e to the u, and then du over 4. We can take the 1/4 out front, so then we're left with 1/4 the integral of e to the u du, And the integral of e to the u is just going to be e to the u plus c. So 1/4 e to the u plus c, some constant. Replace the u, e to the 4x plus c. And technically when you distribute it out, the constant's still going to become a constant, just multiplied by a quarter, so it's going to be e to the 4x plus c.